Hello and welcome to the third tutorial for DXEngine. In this tutorial I will show you how to get an asset in the OBJ or FBX format into the game engine, as well as a look into the asset loader and mesh classes, and also more advanced uses of input components. By the end of this tutorial you should have a 3D model rendered to the screen and be able to control it with the keys on your keyboard. I've already loaded the project through the project loader, and since last time I've commented the code from tutorial 2. As you can see here, I've just commented to say that we're loading in only the vertex and pixel shaders for our UI shaders. We're also creating our asset loader here and binding it to the locator. The asset loader does load in the DX asset files, 2D textures, and also the mesh loading in mesh instances. Here we're loading in our scene file. As it says here, it invokes the asset loader to load in our asset files and update our mesh instances. We're then binding our mesh buffers so then we can bind our texture information correctly. That's it for that. Firstly, we'll go back into our project manager and load up the asset tool. To bring in an OBJ or FBX file, all we need to do is simply drag the file into the viewport with the DX logo. So what I'll do now is we'll go into our sample files folder provided in the engine, and we'll drag our FBX file into the viewport. As you can see here, we've got our model. You can zoom in and out with the mouse wheel, and you can rotate by holding the left mouse button and dragging in the viewport. If we want to bring in textures to our model, basically the same thing, but all we need to do is drag our textures into the specific slots allocated for textures. Next, we need to assign an identifier to our 3D model, in this case Troll Cleric, and click the Add button. Finally, click the Export button and save the file in your project's asset folder. Call the file Troll Cleric Pack. For a more detailed explanation on the asset tool, click the annotation in the video. Now what we can do is close down our asset tool and go to the scene XML file that we looked at last time. I already have it loaded up. What we can now focus on is another element of the scene builder, in this case the DX mesh element highlighted here. This element helps the engine display a 3D model in your scene, including one of the asset packs already loaded in. As you can see in the asset section, we're loading in Troll Cleric Pack, as well as another pack called Engine Required. This pack contains 3D models required for rendering height maps and skyboxes, so we need to keep this pack loaded for later. Coming back to the DX mesh element, we can see that we need to provide an ID, X, Y, Z and Z position as a minimum. We can also provide rotation and scaling if necessary. Although the coordinate variables are easy to understand, the ID requires a small amount of explanation. To apply some scope to the ID, the first part must include the file name of your asset, minus the file extension, in this case Troll Cleric Pack. After this, add a colon, then the identifier we gave the 3D model in the asset editor, in this case Troll Cleric. That's all we need to do here, so if we jump into our code from last time, what we need to do is scroll up to where we're loading in our shaders. Basically the same routine as last time, but this time we're loading in our main shaders. These shaders are just a generic shader which render our main 3D models. So what I'll do is I'll just jump ahead here. As you can see here, we're loading in our vertex shader, pixel shader, hull shader and domain shader this time for our main shaders, located in our main shader folder. As we've already created our asset loader down here and passed our scene file, all we need to do now is build and run our project. And there we go. We have a part of our 3D model in the scene. As we bound an input component from last time, what we can do now is press our key bindings so we can move our camera about the scene. We can also change the rotation of our camera by holding the left mouse button in the window and dragging. That's it for 3D model rendering. What we can do now is bind an input component to our 3D model here. Basically, we can use the same input component from last time, but just change our key bindings. So what we'll do now is we'll close our window, then we'll scroll down to after we've actually loaded in our 3D models. Firstly, we need to get the mesh that we've loaded into our scene. So we need to create a new local DXMesh variable. We'll just call it mesh. And then we need to get our renderable from the asset loader, calling get renderable, and then providing our identifier, control cleric pack, control cleric. After this, we'll just scroll back up to where we declared our last key bindings, copy these, put them down here. We'll rename our variable to control key bindings, and then also change the input keys to I, K, J and L. Next, we need to create a new player input container to control our mesh. So what we'll do is we'll declare a new DX player input object, and we'll call it controller. We'll then create the object, new DX player input, and similarly to the last tutorial, we need to pass in our H instance, window handle, and then just zero the translation and rotation. And then pass in our control key bindings. Finally, to get our input controller to actually influence the mesh, we need to bind our input component. We do this by calling the DXMesh method bind input component. As we only have one mesh instance, we just pass 0 in for our mesh instance index, and then we need to pass in a IDX input component object, in this case appointed to our controller. What we'll do is we'll just encapsulate that in an if statement. So if the creation of our controller fails, we don't actually come up with an error. That's it, and then all we need to do is build our project again and then run it. There you go. So if we move back a little bit with our normal camera, and then what we'll do is we'll press the I, J, K and L keys, and then we can move our actual 3D model around. It may look like I'm just moving the camera around at the moment, but what I'll do in a future tutorial once we've got a height map in is I'll actually show you it there again as well. Finally, we'll have a quick look at the mesh and asset loader classes. First, we'll look at the asset loader. So we'll open up our Solution Explorer and then go into our DX asset header first. As you can see, it stores many things. Firstly, a map to store all our renderables. These are all the DX mesh objects that we load in through our scene parser. Secondly, we have a structure to store texture info. In a future release, these textures will be actually unloaded when they're not used, and then when the engine detects them about to become in use again, it will load them in before they're needed. Finally, we also have UI text info, which also stores a shader resource and also the dimensions of the texture, and also another map to store our renderable UI textures and bitmaps. This class also includes a multitude of functions. The main ones we want to look at are the load asset file and also the bind meshes function, which we have used already. So what we'll do is we'll just go into our DX asset CPP file, and then we will scroll down to our load asset file. Here, what our scene parser will be doing is passing in a file path from our pack tag, like we've seen here. What we then do is we open that file and then read all the text information in the file, create our shader resources here, and then add our textures to the texture bank. Finally, in this case, we'll then read our mesh information by reading the number of assets in the file and then looping through and reading all of our mesh information. This is where we create our new mesh object, and this is where we'll go into now by right-clicking and clicking Go to Definition. What we'll do at this point is just go into our DX mesh CPP file and then scroll up to the constructor that we need, which will be here, which requires our DX file class, which I'll go into in a future tutorial, and also our texture index offset, which is calculated by the asset loader. What we're doing here is just initializing a bunch of variables required by the class, and then we're loading in our mesh, our DirectX mesh. So if we right click and click Go to Definition, we first read our mesh header. This is a 200 byte header for storing various different pieces of information, such as how many vertices it has, if it has animation or not, and also its identifier. After the header's been read, we actually go down and read in all of our mesh information. Then we load in our texture indices here, and then if the 3D model has animation read in the header, then we can go and load in our joint hierarchy. I'll probably go into this in a later tutorial, but if not, you can have a quick look at that function for yourself. That's it for today. Thank you very much for watching, and in the next tutorial I'll teach you how to create a height map with the height map editor and loading it in through our scene XML file.